Topic: Types of feeds, subdivision of feed and a feed flow program. At the end of the lesson you should know and understand the following content. Classification of animal feeds. The concept, roughages and concentrates. The characteristics of roughages and concentrates. The description of different types of roughages and concentrates. The schematic representation of different types of animal feeds. The functions, importance of roughages and concentrates. Subdivision of feeds. The comparison between protein-rich and carbohydrate-rich types of feeds. Examples of protein-rich and carbohydrate-rich feeds. Supplements to rations. The different ways of supplementing minerals, vitamins, non-protein nitrogen, and growth stimulants. Planning a feed flow program. The terminology, feed flow program, maintenance and production ration. A brief overview of the person square method, feed formulation. Calculation and the drawing of feed requirements using a single person square method. The interpretation of the person square results for feed mixtures. Fodder/feed flow/fodder production planning. The importance of fodder flow/fodder production planning. Basic calculation of a feed/fodder flow program for a group of livestock. Number of animals and feed needed over a period of time. Learning content that has been dealt with in previous grades must be in line with the current content. Grade 12 Term 1 Week 4, Digestibility of feed. The purpose of this lesson is to study the content related to types of feeds. Concepts and skills. Types of feed diagrams. Concentrates. Concentrates are feeds that contain a high percentage of digestible nutrients and little crude fiber. Concentrates are feeds with a small volume per unit mass. This means that concentrates are not bulky. Characteristics of concentrates. Concentrates have between 60 to 85% total digestible nutrients, TDN. Concentrates are not bulky, because of the low crude fiber content. However, they are generally quite expensive. Types of concentrates. Protein-rich concentrates can either be of plant origin, such as lupins and oil cake meals, soybean, cottonseed, sunflower, canola and groundnut, or of animal origin, such as fish meal. Protein-rich concentrates contain more than 12% digestible protein. Energy-rich concentrates, such as maize, oats, barley, wheat and molasses, contain a higher percentage of digestible carbohydrates and less than 10% digestible proteins. Functions of concentrates. Some animals, such as pigs and chickens, cannot digest roughages and are fed mostly with concentrates. In ruminants, concentrates are used to balance roughages according to the needs of the animal. Concentrates are used to increase milk and meat production. Concentrates are necessary for the fattening or finishing of animals. Concentrates are necessary for growth and reproduction. Concentrates supply proteins, carbohydrates, fats, minerals and vitamins in the ration. Concentrates are used to balance roughage so that it can satisfy the protein and energy requirements of an animal. Roughages. Roughages contain a small percentage of digestible nutrients per unit mass, less than 60% total digestible nutrients, and have a high crude fiber content, more than 20%. Roughages are feeds that contain a large volume per unit mass, are therefore bulky. Sources of roughage include hay, green fodder, pastures and silage. Types of roughages. Roughages can be divided into protein-rich roughages and carbohydrate-rich roughages. Protein-rich roughages such as lucerne hay, clover hay and groundnut hay contain more than 6% digestible proteins. Energy-rich roughages such as hay, straw and silage contain less than 6% digestible proteins. Functions of roughages. Roughages are the cheapest source of nutrients. This is a saving for the farmer that can balance the cost of concentrate feeding. Ruminants need roughages to maintain a healthy digestive system. Legume roughages are rich in proteins, vitamins A and D, and minerals, especially calcium. Roughage helps rumen development in young ruminants. Roughages supply the bulk to the ration, which is important for digestion in the rumen. Since roughages are generally tasty, they increase the feed intake. Intake of sufficient roughages in the rumen usually prevents bloating in ruminants. Stimulating milk production. Legume roughages are rich in proteins. Good legume roughages are rich in vitamins A and D. Legume roughages are rich in minerals, especially calcium. Supplements to rations. Supplement can be used to replace a deficiency, vitamins and minerals. Increase production, growth stimulants. Increase the digestibility of feedstuffs, non-protein nitrogen. Add antibiotics and probiotics to animal feeds. How to supplement minerals. Mineral licks. Dosing. Mixing with concentrates. Mixing with drinking water. Injections. Cafeteria-style mineral provision. Soil sods. Supplementing vitamins. Adding to the rations, the concentrated rations of pigs and poultry must be supplemented with the required vitamins by adding a mineral/vitamin premix powder to the feed to fulfill their requirements. Drinking water. Water-miscible vitamin A oil is mixed with the drinking water of animals. No more than 1 to 2 days drinking water should be treated as the vitamin A oils deteriorate reasonably quickly when exposed to air. Injections. Vitamin deficiencies may be supplemented immediately by injections in the muscle. Supplementing non-protein nitrogen, NPN. Proteins for animal feeding are expensive. Cheaper non-protein nitrogen, NPN, such as urea and biuret, can substitute natural protein in ruminant rations, but not more than 1/3 of the nitrogen content. NPN does not provide any energy to the animal, and too much can poison the animal. In addition, the carbon skeletons of natural proteins are needed by the microorganisms to be able to build microbial protein with the N obtained from urea. Conversion of NPN in the rumen. In the rumen, the microorganisms change the NPN compounds into microbial protein during the digestion process. The microorganisms first change the NPN compound into ammonia and then change the ammonia to microproteins. The ammonia that is not changed into microprotein is absorbed through the stomach wall and taken to the liver. The liver changes it to urea and recycles it in the saliva or excretes it in the urine. How to supplement urea. A farmer can feed urea on a large scale to ruminants in premixed feeds, mixtures and stock licks. However, it is important that the farmer monitor the supply to prevent urea poisoning. Urea poisoning takes place when animals eat too much of a normally safe lick. The lick or feed has a concentration of urea that is too high. The licks are not properly mixed. It rains and the urea dissolves in the rainwater, which the animals drink. Biuret is less soluble and safer to use than urea, but is more expensive. Supplementing growth stimulants. The increasing demand to feed a growing global population stimulates an increase in the efficiency of animal production. Significant advances have been made in the fields of animal nutrition, genetics and husbandry. At the same time, farmers use more growth stimulants. Growth stimulants are chemical compounds that increase growth rate and include compounds that improve the efficiency with which animals utilize food sources. A whole range of growth stimulants are available for animal production. How to supplement growth hormones. The endocrine system of an animal controls body metabolism and secretes the natural sex hormones. Testosterone, estrogen and progesterone that play a role in the control of growth. Most of these hormones are made in pellet form. The pellets are implanted subcutaneously either behind the ears or in the neck of the animal. In South Africa, non-hormone anabolic compound can also be used that produces similar growth results to estrogen but possesses no harmful health hazards. How to supplement thyroid regulators. Substances that can regulate the secretion of thyroxine are administered because the thyroid gland plays an important role in the metabolic rate of an animal. This will directly affect growth rate of an animal. How to supplement antibiotics. Antibiotics are used to improve the growth of chickens and young pigs, to prevent certain clinical disease conditions, and to prevent harmful microorganisms in the alimentary canal. Antibiotics can be supplemented by adding them to the feed in the feed mill. Antibiotics are only allowed to be added to a ration if there is a prescription from a veterinary surgeon. Antibiotics are kept locked up at the feed mill and their usage is strictly recorded and monitored. How to supplement tranquilizers? Tranquilizers are usually given to animals in feedlots to keep them calm. Animals eat more, resulting in faster weight gain. Tranquilizers can be injected into the animal or mixed with drinking water. Fodder flow program. Types of rations. Maintenance ration. This is the amount of feed that an animal needs to maintain its body mass and composition. Production ration. Is the feed an animal needs in addition to the maintenance ration to do work or produce products such as milk, wool, meat or eggs. Planning a fodder flow program. A good feed flow program on a farm will ensure that there is sufficient food available for the animals throughout the year. To ensure a balanced, functional, efficient ration, the farmer needs to determine the nature and quantity of feed for a ration. To do this, the farmer needs to know the feed requirements of the animal for maintenance and production, the chemical composition and nutrient values of the feed. Properties of a good fodder flow plan. Resources such as felt, land, water, labor, and capital must be used safely, because incorrect usage will weaken the plan. Animal requirements, as determined by their physiological state or by a required level of production, need to be fully met for all stock over the year. The margin over all feed costs should show a positive margin over feed costs. Management flexibility must be applied because fodder is subject to climatic variation. Balancing rations to meet maintenance and production requirements. The composition of feed that is supplied to animals differs greatly. Because no single type of feed can ensure successful nutrition, a farmer will use a combination of feed types to provide enough nutrients to satisfy an animal's nutrient requirements. Using a number of ingredients ensures that the ration is balanced. The ration is palatable. Neither too many roughages nor too many concentrates are used. Methods to balance rations. Nutritionists use advanced computer programs to balance rations. There are also various feeding tables with the nutrient requirements of different classes of animals. These tables give recommendations under normal environmental conditions for growth, milk production, reproduction and health. Factors that influence the nutrient requirements of dairy cows are milk production level, butterfat content of milk, body mass, stage of lactation, pregnancy stage, distance walked or height climbed. The Pearson square method. The Pearson square method is a mathematical tool we use in feed formulation to make it easy to mix two nutrients with different concentrations to get a ration with a desired concentration. In other words, it is a method of balancing rations. We use the Pearson square to determine in which ratio the two nutrients should be mixed to get the desired concentration balance. Overview of the Pearson square method. Step 1. Calculate the feed requirements of the animal according to her maintenance and production requirements. Step 2. Convert the daily DP and TDN requirements to percentages, as all the numbers in the Pearson square have to be in the same units. To do this. Step 3. Next, decide which of the two nutrients you are going to use in the Pearson square. You can only use one. The other one is calculated after the two feedstuffs have been mixed. Step 4. Now use the Pearson square to determine the ratio in which you need to mix the two feedstuffs to get to the required value of the nutrient you chose in Step 3. Step 5. Use the ratio to calculate the amount, for example in kilograms, of each feedstuff to mix to meet the requirement. Step 6. Work out the value of the nutrient in the ration that was not used in the Pearson square. Step 7. Interpret the Pearson square results. How to calculate the nutrient requirement. 1. Subtract the nutrient requirement, middle of square, from the nutrient concentration indicated for feed B, bottom left-hand corner of the square. Write the answer in the top right-hand corner of the square. Repeat this calculation again using the nutrient concentration of feed A, top left-hand corner. Write the answer in the bottom right-hand corner of the square. Take note that the subtractions are made diagonally. Change any negative numbers on the right-hand side of the square to a positive number. 2. After subtracting across the diagonal, add the parts of the two feeds to get the total sum. 3. Calculate the percentage of each feed in the ration. For example, 30/35x100 equals 85, 7% maize in the ration. Look across the horizontal legs of the square to determine the parts needed of the individual feeds in the ration. Going from left to right in this example, the farmer would need 5 parts soybean meal and 30 parts maize to get a 15% crude protein ration. Interpretation of person square results for feed mixtures. 1. Subtract across the diagonally. A. 15% to 10% equals 5 parts soybean meal. B. 15% to 45% equals 30 parts maize. 2. Add the parts of feed A, 5 parts soybean meal, to the parts of feed B, 30 parts maize, to get the sum equals 35. 3. Divide each part by the total to calculate the percent of each feed to be included in the mixed feed. 4. 5 parts soybean meal equals 5/35 total parts 10/100 equals 14, 3% soybean meal. 5/30 parts maize equals 30/35 total parts 10/100 equals 85, 7% maize. Example. A farmer must make sure that cattle grazing on a pasture get an additional ration with a digestible protein DP value of 15%. The farmer needs to mix two feeds to get the DP value. One feed, A, has a DP value of 18%, and the other feed, B, has a DP value of 6%. In what ratio should the farmer mix these two feeds to obtain the required DP value? Draw a square and place 1. The DP value for feed A at the top left-hand corner of the square. 2. The DP value for feed B at the left bottom corner of the square. 3. The desired DP value of the new mixture in the middle of the square. Working across the square and calculate the differences between the DP percentage values for feeds A and B, and the desired DP value, will give you the parts ratio of the feeds that need to be mixed. For feed A, 15% to 6% equals 9 parts, and for feed B, 18% to 15% equals 3 parts. Write these figures in the top right-hand corner, feed A, and bottom right-hand corner, feed B. These values represent the quantity of the two feeds that needs to be mixed to get the required DP value in the new mixture. The farmer would need to add 9 parts of feed A to 3 parts of feed B. Feed A 18% required parts of feed A, 15 to 6% equals 9 parts. 15%. Feed B 6% required parts of feed B 18 to 15% equals 3 parts. If expressed as percent.
Please like, share, and subscribe to the channel for more future educational videos. Please like, share, and subscribe to the channel for more future educational videos. Please like, share, and subscribe to the channel for more future educational videos.